All right, today we're going to continue talking about our right triangle trigonometry. So we have our definitions of the trigonometric functions. Okay, so what we have is SOHCAHTOA. SOHCAHTOA. If you're talking about a right triangle, meaning that one of your angles has to be 90 degrees, otherwise right triangle trig doesn't work. Right? That's why they call it right triangle trig. So if you have a right triangle, your theta, your angle that you are interested in, because you already know C, that's got to be 90. You have two other angles in the triangle. Either those are both the acute angles. Those are the angles that you can stand at to compute your trigonometric ratios. If you are standing here, then this would be opposite, B would be adjacent, and C would be the hypotenuse. And let's recall that we use capital letters to label our angles, and we use lowercase letters that match their uppercase letters crossways. So in other words, if this is angle A, across from it is side A. Angle B, this is side B. Angle C, this is side C. So your sides always go across from your angles. Now, you got to be careful here. Sine is opposite over hypotenuse, which if you're standing at A, that would be little a divided by little c, because this would be opposite and this would be the hypotenuse. If you're standing at A, your cosine would be B over C, because cosine is adjacent over hypotenuse. Well, adjacent to me is B and hypotenuse is C. You could say, well, C is adjacent to me too, and you're right, but you can't call C the adjacent side, because if it's across from the 90, you have to call it hypotenuse. And then if you're doing tangent at A, it's going to be opposite over adjacent, so opposite would be A, adjacent would be B. And then your cousins obviously are the reciprocals. Okay? That's where SOHCAHTOA comes from. Sine, so means sine is opposite over hypotenuse. So, ka means cosine. Cosine is adjacent over hypotenuse. And toa, tangent, is opposite over adjacent. There's your SOHCAHTOA. But what I wanted to show you is, this is if your theta is right here at angle A. If I change it and I stand up here, because this is also an acute angle, but let's call it, it's not theta because we can't say that it's equal to, but let's call it alpha. Okay? No, that's going to look an awful lot like A. Let's just do B. Okay, let's call that angle B. So if I did sine of B, opposite of B now would be little b, and hypotenuse would be C. So do you see how the names of your legs change depending on what angle you're standing at? Because now up here, this would be opposite, and this would be adjacent, and this obviously would still be hypotenuse. But when I was standing down here in purple, this was opposite, and this side was adjacent. So your legs can change names depending on what acute angle you're standing at. So you've got to be very, very careful. All right, so this says find the value of each of the 6 trigonometric functions of theta. They're telling you to stand at theta, so you're standing here. So the first thing I do is label my triangle according to where they're telling me to stand. If they would have said find the 6 trigonometric functions of angle B, then I would have to stand up here. But I'm standing here, so this is opposite, this is adjacent, and this is hypotenuse. Okay, now the problem is if you have to find the value of all 6 trig functions, see how they gave me C and they gave me A, but they didn't give me B? I gotta have that third side. So we use the Pythagorean theorem to figure out the missing side. So I have leg squared plus leg squared equals hypotenuse squared. So that would give me b squared equals 9, take away 1, because this is 9, this is 1, subtract 1, subtract 1. So b squared equals 8. So b equals the square root of 8. Plus or minus, except for you don't have a negative length if you're talking about an actual shape. So now that I know my parts, I can do sine theta, cosine theta, tan theta, cosecant theta, secant theta, and cotangent theta. Alright, so sine is opposite over hypotenuse. If I'm standing here, opposite is 1, hypotenuse is 3. Cosine is adjacent over hypotenuse. Adjacent to me is the square root of 8. Remember, I'm here, adjacent. Yeah, both of these sides are adjacent to me, but this one is hypotenuse, so this one is the one I have to use, over hypotenuse. And tangent is opposite over adjacent, which is going to be 1 over the square root of 8. Now, you can use the definitions, or you can just flip them over. I'm going to use the definitions, but normally I don't. If I'm finding all 6, I just look over here and flip them over. But cosecant is hypotenuse over opposite. My hypotenuse is 3, and opposite is 1. Secant is hypotenuse over adjacent. My hypotenuse is 3, adjacent is the square root of 8. Cotangent is adjacent over opposite. Adjacent is the square root of 8, opposite is 1. Notice how these are just their cousins flipped over. Now, there's only one other thing you got to do. You've got to rationalize any answers that have radicals in the denominator. Okay? P's good. You can have a radical on top. That's good. It cannot have this radical on bottom. So to rationalize it, you multiply it by itself, and I get the square root of 8 over 8. This one's okay, this one's not okay. Can't have a radical in the bottom. So square root of 8, I get 3 square roots of 8 over 8. And then this one would be fine. So sine theta is 1/3. Cosine theta is the square root of 8 over 3. Tan theta is the square root of 8 over 8. Cosecant theta is 3. Secant theta is 3 square roots of 8 over 8, and cotangent theta is just the square root of 8. There's all 6 trig functions for this angle. Okay? Alright, so you try this one, hit pause, come back when you're ready. And hopefully you got 4. Alright, they want me to find sine of theta. So you got to figure out wherever they stuck theta. They stuck theta here at A, so that's where I'm standing. And from there, this is opposite. 5 is adjacent. And I need to figure out my hypotenuse. So Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So you have 16 plus 25. 16 plus 25 is 41. So the hypotenuse is the square root of 41. So now that I know my missing side, I can figure out that sine theta is opposite over hypotenuse. Opposite of me is 4. Hypotenuse is the square root of 41. I have to rationalize that. So square root of 41, square root of 41, and sine theta equals the 4 times the square root of 41 all over 41. Okay, try this one, hit pause, come back when you're ready. And hopefully you got the square root of 85 over 9. They want me to find secant of theta. They stuck theta up here at B, so now I'm standing here, which makes 2 opposite, 9 adjacent, and I need to figure out the hypotenuse. So, leg squared plus leg squared equals hypotenuse squared. That's 81 plus 4 is 85. So, the hypotenuse equals the square root of 85. And now, to find secant theta, secant is hypotenuse over adjacent. My hypotenuse is the square root of 85, and adjacent to me is 2. Yeah, adjacent to me is 9, my bad. And I don't have to rationalize that, so secant theta equals the square root of 85 over 9. Alright, try this one, hit pause, come back when you're ready. And hopefully you got 7/5. Alright, tangent of theta, they put theta here, so here's where I'm standing. and opposite of me is 7, and adjacent to me is 5. And I don't actually have to, I don't need, for tangent, I don't need the hypotenuse. So I don't really need to waste my time finding that hypotenuse. I can, 7 squared plus 5 squared equals hypotenuse squared. That's 49 plus 25 is 74. So the hypotenuse equals the square root of 74. But for tan, all I need is opposite and adjacent. Well, opposite of where I'm standing is 7, and adjacent to me is 5, so tangent of theta is 7/5. Okay, so now we're talking about special right angles. Okay, in geometry, or in our world really, there are 3 angles that are very, 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 very common. The 30-degree angle, the 60-degree angle, and the 45-degree angle. Well, there's 2 triangles. We call them a 30, 60, 90 triangle because the 3 angles, one of them's 30, one's 60, one's 90. This one we call a 45, 45, 90 triangle because 2 angles are 45 and the third one is 90. And these are very, 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 very common. So we came up with, the mathematicians came up with, what they noticed was every time they drew one of these 45, 45, 90 triangles, I don't care how big they made it or how small they made it, the ratio of sides always came down to 1, 1, square root of 2. In other words, if you made this 5, then this would have to be 5, and this would have to be 5 square roots of 2. If you made this 500, then this has to be 500, and this has to be 500 square roots of 2. Okay? It doesn't matter, remember in your geometry days when you talked about similar triangles, meaning they had the same shape, but they were the different size? Well, as far as angle goes, it doesn't matter how big or small you make the sides. If you've got a 45, 45, 90, you got a 45, 45, 90. And the only one way that happens is if the legs match. There's only, if they've got to. There's no way you're going to end up with 45-degree angles unless your legs match. Your 30, 60, 90, they came up with this ratio all the time. Again, it doesn't matter how big or small they make it. Okay? They came up with a 30, 60, 90. The legs always had to be in a ratio of 1 to the square root of 3 and the hypotenuse to 2. Okay? So no matter how big and small you make it, the sides always reduce down to that ratio if you have a 30 and a 60 and a 90 degree in the same triangle. So knowing that every 30, 60, 90 triangle basically reduces down to this one, and every single 45, 45, 90 reduces down to this one, they came up with these nice little charts for you to memorize. And you can get your sine, your cosine, and tan of 45, and the cousins of the 60-degree angle of the 30-degree angle. That's a lot to memorize. And in my opinion, and I'm cheating a little bit, it's just faster to memorize the unit circle than it is to try and memorize the 3 special angles. Okay? Because I want to show you something that I'm not supposed to show you yet, but I want you to start thinking about it, so I'm going to. They say that sine of 45 is the square root of 2 over 2. Let's look at our unit circle. Here's 45 degrees. There's the square root of 2 over 2. I know they both are, but I'm trying to get you to see something. Okay? Cosine of 45 degrees is 1 over the square root of 2, or the square root of 2 over 2. So if I go to 45 degrees, square root of 2 over 2. Weird. If I do tangent of 45, I get 1. This divided by this, in other words, the square root of 2 over 2 divided by the square root of 2 over 2 comes out to be 1. Let's look at the others. If I have sine of 60, that would be up here. They're saying it's the square root of 3 over 2. Sine is the same as the y coordinate. Cosine of 60 is 1/2. Well, that's the same as the x coordinate. Weird. Let's look at the 30-degree angle. If I go to 30 degrees, it says that sine is 1/2. That's the y coordinate. And cosine is the square root of 3 over 2. That's the x-coordinate. You're starting to think that maybe cosine is the same as the x-coordinate and sine is the same as the y-coordinate if you're going through a point on the unit circle. Huh, sure looks like it to me, just saying. Anyway, they want you to memorize this. However, whether you memorize the unit circle or you memorize these triangles, 45, 45, 90 is easy to memorize because the legs have to both be 1 and the hypotenuse is the square root of 2. The 30, 60, 90, here's how I remember it. Across from the 30 is 1. Across from the 60 is the square root of 3. So in my brain, I'm thinking, all right, I want to put the square root of 3 across from 3 because they kind of match. So I've just got to memorize that, no, the square root of 3 goes with the 60, 1 goes with the 30, and 2 has to be the hypotenuse. In both triangles, there's a 2 in the hypotenuse. It's just that for 45, 45, 90, it's the square root of 2. And 30, 60, 90, it's flat 2. All right, and then just remember the square root of 3 doesn't go across from the 30 like it would make sense to me. It goes across the 60. All right, so it says use figure 5.24, which is this. They don't want you to use the unit circle yet, but I'm going to keep showing you, to find sine 45, cosine 45, and tan 45. If we use the triangle, we're standing at the 45-degree angle. So sine would be opposite, which is 1, over hypotenuse, which is the square root of 2. Okay, 45 degrees would be adjacent, which is 1, over hypotenuse, which is the square root of 2. And 45 would be opposite over adjacent. So now if we clean these up, rationalize or reduce, whichever we can do. I'm going to rationalize here, and reduce here. So I would have sine 45 equals the square root of 2 over 2. Oh, look. I'd have cosine 45 equals square root of 2 over 2. Oh, look. And I have tan 45 equals 1. If you divided y by x, you get 1. The tangent is y divided by x. Or sine divided by cosine. Or y divided by x. Alright, so this one says find sine 60, cosine 60, and find sine 60, cosine 60, sine 30, and cosine 30. So we need a 30, 60, 90 triangle. So if we're doing 60, that means we're standing at 60. And sine would be opposite over hypotenuse, so square root of 3 over 2. Cosine would be adjacent over hypotenuse, which will be 1/2. Now for sine 30 and cosine 30, we have to move up to the 30-degree angle. So now I'm going to be standing up here at the 30-degree angle, which now makes this opposite and this adjacent on that hypotenuse. So to do sine of 30, it's opposite over hypotenuse. To do cosine of 30, it's adjacent over hypotenuse. Yeah? And I don't have to rationalize anything or that. But again, look at your 30 degrees. Sine is y, cosine is x. Alright, this one says find tangent of 45 minus sine of 60. Tangent of 45 is opposite over adjacent, that's 1 over 1. Sine of 60 means stand here and do opposite over hypotenuse, which would be the square root of 3 over 2. And then simplify that. Well, I need to get a common denominator, which would be 2 over 2. Now that they match, and on top I'd have 2 minus the square root of 3. And that's without going decimal, that's as far as I can go. Alright, you try one, hit pause, come back when you're ready. And hopefully you got the square root of 2. 45, secant. Secant is hypotenuse over adjacent. So it would be the square root of 2 over 1, which is just the square root of 2. Okay, they want cotangent of pi over 3 minus cosine of pi over 6. Hit pause, come back when you're ready. Alright, so if I do cotangent of pi over 3, what the heck is pi over 3? Pi over 3 is 60 degrees, so I'm standing at 60, and they want me to cotangent, and cotangent is adjacent over opposite? Yeah, adjacent over opposite. So adjacent would be 1 over, we're going to go cotangent, yeah? Cotangent is adjacent over opposite. So it would be 1 over the square root of 3 minus cosine of pi over 6. Pi over 6 is the same as 30 degrees, so I'm standing at 30 degrees now and doing cosine, which is adjacent over hypotenuse. So let's see. If I get a, rationalize the first one, that's going to be square root of 3 over 3. Minus square root of 3 over 2. I got to get a common denominator, which will be 6. That gives me 2 square roots of 3 minus 3 square roots of 3 all over 6, which gives me a negative 1 square root of 3 over 6. Okay? Alright, your reciprocal identities. Sine is 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. Tangent is sine over cosine. Cotangent is cosine divided by sine. Why do we need these? Well, we can use them to solve problems. They're telling you that sine theta equals 2 over 5. And cosine theta equals the square root of 21 over 5. It says, find the value of each of the 4 remaining trig functions. Well, we've got to draw a picture. You can draw any right triangle and put theta in either of the acute corners. Once you pick your stuck, that's where you're standing. So now I have to fill in my triangle. They're telling me opposite is 2 and hypotenuse is 5. So opposite my angle is 2 and the hypotenuse is 5. And cosine is telling me that adjacent over hypotenuse is the square root of 21 over 5. So adjacent to theta is the square root of 21. And again, my hypotenuse is 5. So I've got sine, I've got cosine. They want tan theta. They want cosecant theta, secant theta, and cotan theta. Alright, well, tan theta is, tan is opposite over adjacent, so that's going to be 2 over the square root of 21. Cosecant is hypotenuse over opposite, so I would have 5 over 2. Secant is adjacent over opposite, opposite over adjacent, so that'd be 5 over the square root of 21. And cotangent would be adjacent over hypotenuse. Alright, so let's clean them up, rationalize where we can. Tangent theta equals 2 square roots of 21 over 21. Cosecant is fine. I have to rationalize this one, which gives me secant theta equals 5 square roots of 21 over 21, and this one's fine. Alright, you try one, hit pause, come back when you're ready. And hopefully you've got 7/3. It's telling me that opposite is 3, hypotenuse is 7, and this is telling me that adjacent is 2 square roots of 10, and hypotenuse is 7. So if I draw me a little triangle here, put theta in this corner, opposite of me is 3, hypotenuse is 7, cosine describes adjacent to me, 2 square roots of 10, and the hypotenuse again is 7. and they want me to find cosecant. Cosecant is sine. If sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. So cosecant theta will be hypotenuse, which is 7, over opposite, which is 3. Yeah? Alright, Pythagorean identities. This is the most famous one. Sine squared theta plus cosine squared theta equals 1. Anytime you see a sine squared plus a cosine squared, you can replace that with 1. Alright, so it says, given that sine theta is 3/5 and theta is an angle is an acute angle, find the value of cosine using a trigonometric identity. Well, if you got sine and cosine, I can say, well, sine squared theta plus cosine squared theta equals 1. But they told me what sine was. Sine was 3/5, but I got to square that. Plus cosine squared theta equals 1. That's going to give me 9/25 plus cosine squared theta equals 1. I'm going to subtract 9/25. I get cosine squared theta equals, if I do 1 minus 9 divided by 25, and math enter it, I get 16 over 25. So now, to get cosine alone, I'm going to square root both sides, and I get cosine theta equals 4/5. And that's what it said to find. Find cosine theta. It's 4/5. Alright, you try this one. Hit pause. Come back when you're ready. And hopefully you got the square root of 15 over 4. So I can write the equation sine squared theta plus cosine squared theta equals 1. I'm going to replace sine squared theta with 1/4 squared plus cosine squared theta equals 1. That's going to give me 1/16 plus cosine squared theta equals 1. So now I'm going to minus the 1/16, and I get cosine squared theta equals 1 minus 1 divided by 16. Math, enter. I get 15/16. So now to get cosine alone, I'm going to square root, which gives me cosine theta equals the square root of 15 over 4, because the square of 16 is 4. And that's what they wanted. They wanted me to find cosine theta. Alright, so this one says use an identity to find the value of the expression. Do not use a calculator. Well, you see, all they're saying, guys, is sine squared theta plus cosine squared theta. They're just giving you the value of theta. As long as these match, and they do, my answer is 1. Okay, so again on this one though, the angles are the same. So that's like saying sine x times cosecant x. Well, that would be sine x times 1 over sine x. The sine x's would cancel, and I would just get one. Yeah? Alright, so you try this one. Hit pause, come back when you're ready. And hopefully you got 1. We've got secant squared 70 minus tan squared 70. Well, let's see. I need to... Oh, well, looky over here. You have this function, but if I got 1 alone, in other words, if I got tan and secant on the same side, minus tan squared theta minus tan squared theta, I'd get 1 equals secant squared theta minus tan squared theta. Well, as long as my thetas match, this property says that secant squared theta minus tan squared theta equals 1. Alright, try this one. Hit pause. Come back when you're ready. And you should get 1 again. These angles match, so I can say cosine theta, or 80. We call it x. Secant is 1 over cosine x. They cancel, and I get 1. Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got 0. You can rewrite, it's not up here. There you go. You can rewrite sine theta over cosine theta as long as the thetas match as tan theta. So this would be tan 50 minus tan 50, which would be 0. Alright, so how do you solve for the missing parts of a triangle? Well, we can use Pythagorean theorem for missing side. Then we're going to use SOHCAHTOA to find the missing pieces. Describe the triangle used to find the trigonometric functions of 45 degrees. So you've got to remember, in a 45, 45, 90, the legs are 1 and the hypotenuse is the square root of 2. For a 30, 60, 90, you have 30, 60, 90. Remember that 2 is on the hypotenuse. Square root of 3, you'd think is across from 30, but it's not. And 1 is over here. Alright, so we are at homework, which means we're done. So happy homeworking, and I will see you next time.